Starting system. Starter motor. The starter motor converts the electrical energy from the battery into mechanical energy for cranking the engine. The starter is a special type of electric motor designed to operate under great electrical overloads and to produce very high horsepower. Because of these design features, the starter can only operate for short periods of time without rest. The high current needed to operate the starter creates considerable heat, and continuous operation for any length of time causes serious heat damage to the unit. The starter must never operate for more than 30 seconds at a time, and should rest for 2 minutes between these extended cranking. This permits the heat to dissipate without damage to the unit. All starting motors are generally the same in design and operation. Basically, the starter motor consists of a housing, field coils, an armature, a commutator, and brushes, and end frames. The starter housing, or starter frame, enclosed the internal starter components, and protect them from damage, moisture, and foreign materials. The housing supports the field coils. The field coils and their pole shoes are securely attached to the inside of the iron housing. The field coils are insulated from the housing, but are connected to a terminal that protrudes through the outer surface of the housing. The field coils and pole shoes are designed to produce strong stationary electromagnetic field within the starter body, as current is passed through the starter. These magnetic fields are concentrated at the pole shoe. Fields have an N or S magnetic polarity, depending on the direction of current flow. The coils are wound around respective pole shoes in opposite directions to generate opposing magnetic fields. The field coils connect in series with the armature winding through the starter brushes. This design permits all current passing through the field coil circuit to also pass through the armature windings. The armature is the only rotating component of the starter. It is located between the drive and commutator end frames and the field windings. When the starter operates, the current passing through the armature produces a magnetic field in each of its conductors. The reaction between the armature's magnetic field and the magnetic fields produced by the coils causes the armature to rotate. This is the mechanical energy that is then used to crank the engine. The armature has two main components, the armature windings and the commutator. Both mount to the armature shaft. The windings are made of several coils of a single loop each. The sides of these loops fit into slots in the armature core, or shaft, but they are insulated from it. The coils connect to each other, and to the commutator, so, current from the field coils flows through all of the armature windings, at the same time. This action generates a magnetic field around each armature winding, resulting in a repulsion force all around the conductor. This repulsion force causes the armature to turn. The commutator assembly is made up of heavy copper segments, separated from each other, and the armature shaft by insulation. The commutator segments connect to the ends of the armature windings. Most starter motors have 2 to 6 brushes that ride on the commutator segments, and carry the heavy current flow from the stationary field coils to the rotating armature windings, via the commutator segments. The brushes mount on, and operate in some type of holder, which may be a pivoting arm design inside the starter housing, or frame. However, in many starters, the brush holders are secured to the starter's end frame. Springs hold the brushes against the commutator with the correct pressure. Finally, alternate brush holders are insulated from the housing, or end frame. Those in between the insulated holders are grounded. The end frame is a metal plate that bolts to the commutator end of the starter housing. It supports the commutator end of the armature with a brushing, and often contains the brush holders that support the brushes.